Hello. Can everyone hear me? Sweet, wunderbar. So I don't know any German except for Prost, Bier, and wunderbar. That's all you need to know, right? Yeah, cool. I don't even know what shader is in German. Probably shader. So this whole talk's going to be in English. Hopefully that will be okay. So I'm going to be talking for about 45 to 50 minutes, maybe, on a crash course to writing custom Unity shaders. This is kind of a topic that I'm trying to condense many, many decades of research down into 40 minutes, or 45 minutes, and hopefully people that come to this talk are like, they come to it going, what the fuck is a shader? It's all like this weird black magic sorcery that's kind of cooked up elsewhere, and then hopefully they leave going, oh, actually, I can actually do some pretty cool shit. Everyone okay with that? Yes. Sweet. Oh, someone's got their hand up.
Just as a notice, I think a lot of us can't see the left third of the screen.
Yeah, I realized that, so I'm going to do most things on the other side. Sorry, yeah. I'll try and talk like this. Cool, awesome. So every time I begin a talk, I like to sort of find out about the people I'm speaking to. So put your hand up if you're a programmer, or you write code, copy-paste code, Google code. Okay, that's quite a lot of people. I love how more hands go up when I ask that bit. Put your hand if you're an artist, so you do the coloring in with crayons, okay? Put your hand up if you're an audio person. Okay, is there any audio people here with beards? Yeah, are you in a band as well? You were in a band, yes, okay, so I've asked that question all around the world, and there's at least one person in the crowd who's in audio, in games, has a beard, and has been in a band, and normally wearing a Metallica t-shirt, like, yeah. Yeah. That's okay. Put your hand up if you're a game designer. So it's basically your job to annoy everyone. Okay, cool. Put your hand up if you work in Q&A. Technically, everyone should put their hands up. That's fine. Put your hand up if you have no idea what's going on and you kind of went for a stroll this morning through Urban Spree and then you saw a load of people come into a barn and thought this might be fun. Okay, there's some hands. Okay, cool. Put your hand up if you're from Germany. Oh, wow. Put your hand up if you're not from Germany. Wow, okay, that's awesome. So by this point, everyone's put their hand up and everyone's awake from the hangover, so this is a good sign. Cool, I'm going to get on with it. So my name's Andy, I'm a Unity evangelist. My family think I've run away and joined a cult circus. My granddad actually said, do you do Tom Cruise stuff? Whilst that looks incredibly fun to sit on the top of a building, I don't think that's photoshopped. It is probably kind of the complete opposite of what I do. So I'm a tech evangelist for Unity Technologies in Europe, Middle East, Africa, and Russia. So a few places. I'm on Twitter. It's just my name, but without a space, so it's quite easy to remember. And basically, I get all the juicy stuff that Unity's working on, build stuff with it, and show people how to do it. So in this example, I built shaders, or written some shaders, then come and show you how to write shaders and stuff. That's basically my job. It's a very tiring job, but it's a fun job. So yeah, I'll be hanging around. So I was here last night. I'll be hanging around next 2 days. So if you want to come say hi, high five, play genital jousting, the game, of course. My girlfriend might get annoyed. Yeah, just come up and say hi. Awesome. So shaders, right. Super scary topic. Lots of people are very scared of shaders for many, many reasons. They're scared because of sometimes they'll write a shader or modify a shader in Unity and it'll turn pink. That's actually a built-in shader you can get the source code for, and I'll show you a bit later on. Other reasons why people are scared of shaders is they see stuff like this, which isn't actually that bad because you have words that you recognize like vertex and polygon and N and weird E. And you have stuff like this, and then you see stuff like this as well, and it can be quite intimidating. You know, shaders is quite an arty-related topic, so like, why do you have to understand stuff like this? Which I'm not even sure that does. I just Googled shader algorithm and just found the first four. Or even stuff like this, like someone's in the crowd here saying, oh yeah, same as Gorard theory, yeah, get the specular. But most people are not. People don't want that. So I looked at a lot of shader talks that are online, and a lot of them are these big fancy pants algorithms that like one person in the crowd actually understands. The rest are saying, what? So this is going to be a talk where I don't go through these algorithms. It's going to be like a no bullshit type of like talk, kind of distilling down lots of tech into very simple terms. Yeah. So I went to Wikipedia as a viable resource, and it says a program that tells a computer to draw something in a specific and unique way. And that's basically how the shaders in Unity work. So put your hand if you use Unity. That's probably a good question to ask. Okay, cool. So if you use Unity, there's several reasons why you would write shaders as opposed to just use the built-in ones. Like Unity comes with like 45 or 50 or whatever it is built-in shaders, but they're very, very specific. So, you know, why learn it? Why learn this thing with the exclamation mark? So the built-in shaders are for generic use cases. They're not for use cases that are like very specific to what you need it to do. I need to make a shader that cuts an object into cheese, right? We're not going to ship a cheese shader into Unity. That's ridiculous. Yeah, someone's like, oh, yeah. We should probably actually do that. I'm going to show you how to make a cheese shader in this talk. So yeah, I should put that into the source. So yeah, built-in shaders are for generic use cases. You know, if you really want specific stuff, you're going to have to write it yourself. You can do unique and custom visuals. It's actually really easy to do. You can do some really weird stuff. I did put shit here, but it's been recorded, but I've just said shit, so I've ruined it. You could do some really weird stuff with shaders. The really cool thing is if you mistype a shader or you multiply a value rather than plus a value by accident, you can still get some really cool, funky results. Optimization is super important. A lot of people will use kind of the shaders that have all bells and whistles and are super complex and try and put this on an iPhone 4, and it just horribly goes wrong. So I'm going to go through a bit of that. Shader skills are gold dust. So part of my job is visiting studios and asking them like how many programs you have, how many artists, kind of how do you build games and stuff. And I'd probably say 9 out of 10 studios, these are studios like 20 plus, don't have a single shader program in their entire team. But they're like, do you know any? We want to hire them. So hopefully everyone here, eventually by me doing this talk, it's going to be less gold dust, it's more like silver dust, but yeah, that's fine. They aren't actually that scary. When you break them down, they use a lot of common concepts that you have if you can write any other script. So there's variables, there's methods, there's includes, there's all sorts of stuff. And they're actually very fun to play with. So I do this quite a lot whenever I'm traveling, write weird shaders next to grandmas, and they're just like, what are you doing? This looks weird. So Unity shaders. So it's written using NVIDIA CG, so it's the C for graphics, but it's wrapped in Unity's shader lab code. So this is kind of a bit weird. So basically look at my adventurous naming, shader name.shader. So every shader in Unity basically has these two parts. So you technically write two languages when you create a shader. You have shader lab at the top and the bottom, or it's more like wrapping the content, and you have CG that's glued in the middle. And shader lab is basically the interface between Unity and CG. So for example, when you go into Unity, and if I select this cat, shader lab is basically the thing that exposes the content publicly. It's the thing kind of like Unity's middle language to say, okay, take the content from Unity or the Unity engine and put it into the graphics. Now take the stuff from the graphics and put it into there. So shader lab's kind of like that middleman or middle woman, whatever it may be. Oh, wrong slide. Yeah. And CG is all the stuff that does all the dirty stuff, the cool stuff. So you kind of have to learn two languages. Shader Lab's made by us, so we've got lots of documentation, and CG is written by NVIDIA, so they've got lots of documentation as well. So I'm going to cover sort of two shaders. You can write various other shaders, but I'm going to cover vertex and fragment shaders and surface shaders, because those are typically the two that come up quite a lot when people write shaders. So I'm going to do vertex and fragment shader first. But here's the comparison. So rather than me showing like some big fancy pants algorithms, here's kind of a simple thing. So the vertex and fragment shader is building a car from scratch. You can choose the car to have one wheel and a squeaky horn and be pink and have a giant balloon on the top. You build it up from scratch. It's probably not going to drive very well, but you can choose what actually goes into this. So you can see that we have an engineer here fitting a steering wheel, but she could not fit a steering wheel. It's up to her choice. A surface shader is buying a nice fancy pants car and it already does everything on it, but it's kind of a bit too heavy if you want to race it in go-karting or something like that. So you kind of need to choose which one you're going to do. Vertex and fragment is often better if you want to optimize things or do very specific things. So let's say you're building a game for, like let's say you're building a Match 3 clone or whatever on mobile. You don't want to calculate global illumination and reflections and all this stuff. You just want to draw something on screen that like looks like cheese or whatever. Whereas surface shaders, like all the fancy pants stuff, all the shininess and all the glowingness. There is pros and cons to using each, and I'm going to show you the pros and cons to each of those. But yeah, so you kind of have to choose which one you can do. Now, the funny thing is most people who target low-end devices will instantly go with a nice brand new shiny car because it makes sense, right? And it's less code. However, you should probably be doing this one. Yeah, building your own car. So yeah, I'm going to talk about vertex and fragment shader first. So I'm going to go through various steps. So the first thing that the shader flow does is it gathers the information to use. It actually needs to get some data to actually draw the object. In this case, I'm using Robot Kyle. Yep, I'm using Robot Kyle. Well, one sec. Robot Kyle is kind of like a model asset. So you need to get the content from that model asset and then draw it in your world. So step 2. is the vertex function, because it's called a vertex and fragment shader. So the vertex function takes the model, so you can see here we have all the model and the wireframe, and it builds the object in the world. It doesn't build it in the screen, it builds it somewhere positioned in your 3D world. Step 2 is the vertex to fragment. This is actually a really important step. It basically takes the object that's in your 3D world and draws it on the screen. So if you think of it like taking a selfie, right? No, that's a bad example. Okay, taking a selfie, you're kind of like, your entity is a vertex, but when you take that selfie, you're almost taking a snapshot of it. That's the vertex to fragment bit. And then you put all the crappy filters on, like the Bob Marley filter or whatever. That's then the next step, which is actually coloring it in, the actual fragment function. So you have this step. You have the asset data. You then have the object being drawn somewhere in the world. You then have kind of the snapshot to the screen, so you can see you have the Unity blue around the outside edge. That's basically then being drawn on the screen. And then you have the fragment functions, where you basically color in every single individual pixel. So where you do lighting, where you do reflections, where you do any visuals. And because you have each of these steps, you can do lots of interesting things. So I'm going to show this a bit later on. So for example, the vertex function, you could take the object and make all the points and explode them all on the GPU without having to animate that or redraw the mesh every frame, which is really expensive. You can actually do that all by going to all the verts and then displacing them. Or in the fragment, you then calculate the lighting or make the lighting backwards or make all shadows red and stuff like that. And then it's done, the object is rendered. So if you go through the code, so it's actually quite simple. So what we have here is we have a struct when we write in CG of app data, and then we're getting the data that we want from the model. So in this case, we're getting the position of all the vertices, and we're also getting the UV map. And an object might have multiple UV maps or various other data, like normals. The next section is the vertex function. I'm going to write this a bit later on, but here we basically take the app data, the data that we've got from the model, and then we put it into here, and then you could build your object in the scene. So this is where you then do all the stuff like make all the points sort of like animate and do all sorts of cool stuff. So that's kind of the building part. Next part is V2F, the vertex to fragment. Fragment. And in this, you then have to take that data from here, and you have to then pass it through kind of like a narrow gap, in this case, the position on the screen and the texture coordinates on the screen and stuff like that. And then you have the fragment, which is another function where you basically then set up what the thing actually looks like. So if you think of it like this way, this is basically going to IKEA and buying a chair, like that's kind of flat packed. This is then building your chair. This is then taking a photo of your chair, and then this is then coloring in that photo of that chair. Does that make sense, hopefully? Or is everyone still hungover?
Perfect sense.
Perfect sense. Oh yeah, that's a very good reaction, yeah. Could you say it louder? No, I'm joking. And then your object is rendered, so it ends up returning a color. So it basically does this. You have your object data, it then goes to the vertex function, creates your object, it then takes a snapshot, puts it to the screen, and then you colors it in the screen, in the object. Now, I say object data here, because that's stuff like models and like the actual model data, but you can also pass in custom data. So this is where you can write scripts that get your things to do different things. Custom data could also be lighting, and it could also be animations or textures or anything like that. You can even pass like audio data into like the shader to actually have it animate using audio and stuff. So you can do all sorts of cool stuff. And you can pass it in either to the vertex or the fragment function. So demo time. So I actually really, really hate PowerPoint, not as much as iTunes. So yeah, hopefully no one here from Apple heard that, but Apple didn't go do anything, so yeah. So we have here a cat, and I'm going to use this cat. So you can tell we're a super serious company, right? So I'm going to use this cat, and the cat's got the same material applied to the sphere and also onto the quad. So you can actually see kind of what's happening in 3 different instances. One of it being rolled out like a pancake, one of it just on like a sphere. I try not to use a cube because I hate it when people use cubes to demo stuff, and one on an actual model. So we're going to go to our cat, and the first thing we're going to do is we're going to create a brand new script. Well, if I go to my cat, you'll notice that the cat's using the default standard shader. Now, that's a surface shader, so it has all the fancy pants bells and whistles. We don't want to use that. We want to write a custom thing, a custom shader. So we're going to go to Create, Shader, and you'll notice that we actually have a couple of options. I'm not going to go too much into all of these, but I'm just going to create an unlit shader to begin with. And let's call it, what should we call this? Amazing Shader. It wouldn't be an amaze talk without, there being a shader, right? And then let's open that up. Oh, sorry, I'm standing on the wrong side. One sec. Is that a bit better to read? Yep. Okay, so amazing shader. So we already have a lot of these data and all of these fields already filled in. But what I'm going to do is I'm just going to delete it all and start from scratch. So I'm going to build up the shader from the beginning. So first of all, we need to define it is a shader. And next, we then need to give it a name. So I'm going to write custom / amaze. Let's make this bigger. / funky shader. OK, so that we begun creating our shader. So if I then go to my cat and zoom in here, you'll notice that we have custom amaze funky shader. And it will return pink, because we haven't actually given it a color yet. OK, so far so good. Unless you make your whole game out of pink objects, in which you can just leave the talk right now. But yeah. So next thing that we do is we define properties, which are like public variables. That's where you feed that data in. So the property section is basically all the stuff that pops up like here that you normally see in a shader. And the next thing that we're going to do is we're going to create a sub-shader. So sub-shaders are kind of weird. So in one shader, you can actually have multiple sub-shaders for different things. So if you're shipping a game to, say, like Xbox and HoloLens and iOS and something else, you may want to write different versions of that shader. So on like an iPhone 4, you don't want like fancy pants lighting, but on HoloLens, you do want fancy pants lighting. So yeah, most studios actually don't bother writing multiple sub-shaders. They just write kind of like a mobile version specifically, and then kind of like Xbox version specifically, and I'm just going to do that. The next thing you can do is you then create your passes. So passes are basically every time it's being drawn on the screen. Oh, wow, cool. Every time it's being drawn on the screen. So a shader can have actually multiple passes. So a good example of this is Left 4 Dead. Has everyone played Left 4 Dead? Yeah, OK. So in Left 4 Dead, you have the characters, and they have all their details and what they look like. And then you have an outline around the outside edge. So that's using two passes, one to draw the character and one to draw the outline around the character. And I'll show you how to do a Left 4 Dead shader a bit later on. But so you can actually have like 10 passes in one shader. Pretty cool. You can do 10 different steps of stuff. However, every pass equals another draw call. So you could have 10 passes for like your blade of grass, but then that's 10 draw calls on your screen just to render that blade of grass. So my suggestion is try and compress them as much as possible into one pass. Some shaders, like the Left 4 Dead one, you kind of have to use multiple passes, but yeah, so it's up to you really. But try and condense it. That's the right way. OK, so that's what we need to do right now. We can also do some other stuff. So like with anything in Unity, there's lots of magic methods that allow you to do lots of weird stuff. So we have an element here called tags. So tags allow you to determine render types, or where it actually is rendering, before the skybox, after the skybox, if it's opaque, if it's transparent. In this case, I'm going to make it opaque. And we have the documentation saying all the different tags and stuff. OK, so next, I'm going to then begin CG. So like in my, oh, it went pink again. Don't worry about that. So like where we have here, I've already done this chunk here and this chunk here. I'm now going to write all the CG stuff in the middle, the stuff with the vertex function and the fragment function. Now, I'm actually incredibly lazy, and I've already written this all before. Copy and paste, yeah. OK, so everything that I've written before, oh, wrong. OK, everything I've written before is everything that was in those slides, except there's a couple of new things. So firstly, when we have our vertex and fragment shaders, the vertex to build the object and fragment to then color in the object, you have to define those as functions beforehand. I'm not really sure why, but you just do. Next here, you can also use includes. So Unity actually comes built in with lots of CG include libraries to do different stuff. So for example, I'm importing Unity CG, which is a whole bunch of maths functions that you can then use that are built into Unity. You could also do stuff like include, I think it's like Unity lighting.cjink. So you can actually import the lighting library for Unity and then use that. Because using vertex and fragment, and I don't want lighting to compute, I can get rid of that, and lighting is not calculated on my object. So yeah, that's kind of one way that you can do that. You can also write your own custom ones if you want to. So the next thing here is gets the asset data. So I've already set this up, and it's basically what I showed. Now the thing I have to explain here is what kind of float 4 means, or what that stuff does. So you can have different types of data. So you can have float, fixed, and half. So float is basically an undetermined floating point. So this, for example, means it will return data that's like dot 1, 1, 1, 1, 1, 1, 3, 3, 3. It will basically keep going and stuff. It's longer, it's more precise. Fixed basically then clamps it. I think it's 2 or 1 kind of like floating point value. So fixed is better for mobile because they don't have to calculate extra data. But the way that kind of like mobile's going is you could pretty much write float for everything and it should be fine. And half is kind of somewhere in between that. So here we're going to write float 4 for the vertex. This is the name of our reference. And we're going to get the position. So I could call the same thing. I could call this a maze, like vertex a maze, and then I have that reference. So it's just like a variable ref name. Now, the 4 and the 2 mean how much data is going to be in there. So for example, a position is X, Y, Z, and W, and whereas a UV would be X and Y. A color would be RGBA. So you basically determine what data you want to get. So if you wanted to just get the R channel for something, you could just write float 1, because you just want the R channel and stuff like that. Does that make sense? Hopefully, cool. Right, I'm going to get them doing cool shit in a second. This is all the boring stuff. Okay, next up. So V2F. So this is basically going to take stuff from the vertex and then pass it into the fragment. And I've already set this up. So I'm going to pass in the position and the texture coordinates to the screen. So here's the vert. This is where we pass in our app data. We're then going to return it out, and you build your object here. So this is where we can actually do some pretty cool stuff. So the first thing I'm going to do is I'm going to output the position, because you can see here that we have position here. I'm going to output the position of all the where the object's pieces are into the screen. So you have to use this really weird line of code, which is multiply the Unity underscore matrix underscore MVP. I'll explain that in a second, by the UV. So what it's going to do is it's going to get the UV of the object. Oh, wait, not the UV. Okay, yeah, that would totally break. Vertex, yeah. So we're going to get the position of all the vertices and draw them on the screen. Now, MVP doesn't mean most valuable player. Matrix doesn't mean you're enabling the matrix and all that crap. What this does is it's basically model view projection. So it's going to get the model, it's going to get the view from where the camera is, and it's going to then project it into the screen. You could do stuff like model view, and you just get the view of where the model is, but not project it and stuff, so if you want to do some funky effects. So yeah, hopefully that will make sense. So the next thing that we get then is we then need to take the UV data and then pass it into the screen as well. So this is actually really simple. You just write out.textureCoordinate equals in.uv. So we have the in and the out. Okay, cool. We're going to come back and I'm going to animate it and do all sorts of weird shit, but we need to make it actually render first, which is cool. So the next thing that I need to do is I need to actually tell it what it looks like. Currently, my cat is pink, right? That's not very good. I don't want it to remain pink. So what we're going to do is we're going to actually do the flow that you typically do with a shader, where you actually build it up piece by piece. I'll put it to that side of the screen, sorry. So what we're going to do is we're going to add a variable. They're going to import the variable to CG, and then we're going to use the variable somewhere, which is kind of like a typical method of when making a game. You add in kind of the data, you then use the data somewhere else. So we're going to go to our properties. So what we're going to do is I'm going to make a color, because that's kind of like the first thing that everyone does. So main color, no, instead of main color, it's going to be like amazing main color. I'm going to see how many amaze puns I can make before people just get fed up. We're then going to set what the variable type is. So in this case, color, but you could also have float, you could also have texture and stuff like that. And then I'm going to just set the RGBA to be 11111. Okay, so if I then go back to here and set my cat, I then have amazing main color. And I can set this to anything, but it's not actually going to the cat at all. So every time you add a property here, it's then going to then populate that property publicly. So as well as doing the cat, I'm then going to do main texture, and let's call this actually no, come on, that's main cat texture. Now, instead of importing it as a color and exposing that as a color, we can import it as 2D, because you can have a 2D texture, and you can also have a 3D texture, which is kind of like a cube map. You can have different types, so it's 2D, and we can then set the default color to be white, and then we put those there, but I'm not really sure why. We just do. You can tell I really know my shit, right? Not really. So yeah, so if you think of it here, this is our reference name for the variable later on, like vertex or like my speed or whatever. This is what is being displayed publicly into the editor, so you can write stuff like amazing color. You can write messages for people who aren't programmers to then, see. This is then what type of variable it is, and then this is kind of like the initial populated data. So if I go back into here, main cat texture, and we can then give it a different texture, but it's not actually going to do anything. So if I make my cat bricks, it's not actually going to do anything because it's not being used. Okay, so let's now import it. So currently we've written everything in Shader Lab, and we need to now import it into CG. Because they're two different languages, you have to get one from A to B. Luckily, it's actually really easy to do. You just need to write and convert it. So color's going to return RGBA, that's 4 values. So what we're going to do is we're going to write float 4 is main color. Now, a texture is going to return 2 values because it's X and Y, so it's going to be float 2 and main texture. So those are now imported from ShaderLab into CG. And now we can actually use them. So in this case, when we end up coloring the object, we then need to return 4 values, so RGBA. Now, the kind of weird thing to think about with vertex and fragment is they're almost like glorified for each loops. So with the vert function, it's then going to loop through every single vertices on your object, almost like instantly, very constantly. And with the fragment, it's going to loop through every single pixel that the thing is on the screen, which is good and bad. It's good because you can now access every single pixel of the object and randomize it and do all sorts of weird shit. But it means that you're looping through every single pixel on the screen. It's why full screen image effects are quite expensive, because it's looping through every single pixel on the screen several times. And it also has to factor in transparency. So luckily, what we're making isn't too complex. So what we're going to do here is we then need to end up with an end color. So let's do that. So what we're going to do is I'm going to make a float for texture. I'm cheating here. Main texture color. So we're going to get the RGBA value of the texture color. And we're going to set texture 2D. And then we're going to pass in our main texture by what we want to do. So we could scroll the texture. We could actually pass in the texture using the position of the object in the world or any RGBA value. But instead, what we're going to do is we're going to import the texture coordinate of 0. So yeah, we're then going to take the texture and wrap it around the UV. Then what we're going to do is we're going to set end color equals main texture color multiplied by the main color. So we're just going to take whatever the texture color is and then tint it. Okay. So this is kind of the boring stuff. I'm going to get into some weird stuff in a second. And why did that not compile? Funky shader, line 52. Pardon? Whereabouts? Sorry, I'm kind of hungover. Oh, yeah, shit, sorry. So we need to sample it, yeah. Ooh. Yeah, no one cares about that script. What the fuck? Pixel frag. Yeah, what the hell, man? This is super... Oh, shit, yeah. Again, I'm hungover, so I realized that I put this the wrong way around. So that's just then going to tug it to the screen. Wait, okay, cool. It does, yeah. So ignore everything that just happened. So here we can then apply our color, which is, okay, it's doing cool stuff. And here we can then apply texture. So if I apply bricks to it, you can see that we now take bricks. It's then going to wrap it around the UV. In this case, you can see the bricks is kind of like sliced up. Or I can just give it my cat texture. And then we have a cat. So we now have an unlit, doesn't compute any lighting, simple cat. Well, hey, okay. So now I can actually do the cool, fun stuff. I could place cracks on it or like, yeah, do sorts of weird stuff. So now we can actually do the fun stuff. So now we have this set up, we can then do things. So what I'm going to do next is I'm going to animate the cat on the GPU as opposed to the CPU. So I'm going to take all the points and then animate it. So the first thing I'm going to do is I'm going to set up a variable called extrude amount, so how much it extrudes from the object. So extrude that cat. And I'm going to set this up to be a float, so it can be any float value, and set this to be like 1. Yeah. I'm then going to import that in, because I'm just importing one value, so you just write floats and then extrude amount. And what we want to do is, if I want to get all the points on the cat, I don't want to do it in the fragment where it's being drawn, I want to do it just here. So this is where, just before I send the cat's object to the screen, I can now mess with it. So what I can do here is I can write, the first thing I need to do is I need to import the normals for the cat. So that's basically the normal direction of all the vertices. So we have here, import all the normals. And then here, I can then go in.vertex.xyz, so we're going to get every single normal and every single vertices, and we're going to plus that by in.normal.xyz, so we're getting the direction that we're facing, and multiply that by extrude amount. So what we should have is the cats should, you then have kind of like a, yeah. And it's a bit different for me just like grabbing the cat. So if I set this back to be like 0, it's a bit different for me just grabbing the cat and then scaling it, because the scaling it's then going to take everything and keep its proportion. Instead, what it's actually doing is it's actually getting every single sort of vertices and then sort of pushing it out slightly. So yeah. I actually feel really sorry for it, because you could do like minus 0.1. Oh. Yeah, and that was horrible. So if I went to my artist and said, oh, could you draw this, like with fangs and stuff? So the sphere, you can see not actually much changes with the sphere, because the sphere has even proportions around the outside. All the normals are facing outwards. And the same with the quad. You can see the quad is just moving back and forth, whereas the cat really kind of gets a bit puffy. Okay, so that's kind of fun. So let's actually do something that's a bit more fun. Obviously, the shader does not ship with Unity, but you could do some cool stuff. So what we can also do is we can actually animate it. So what I can do is take this value, multiply it by underscore time. Okay, let's set this back to be like 0. Oh, where is it? Okay, and so let's be like 0.1. Okay, so what it's basically doing is it's constantly increasing in size over time. Now, this is a weird thing that I didn't really understand to begin with when I started doing shader stuff, is the time value in a shader is actually a float 4 and has 4 different separate time values. So that means the x is on a separate time value to y, is on a separate time value to z, is a separate time value to w, which I think is insane. And basically the way it's set up is x is kind of half time, y is real time, and z is like double time. So we can set this to just be y. So, oh wow. So 0.01, we can see here that we have the cat, and it's a bit messed up with time. So what I can do next is properly fix it. And this way, I can wrap it in a sine curve. So what it's going to do is it should, where's the cat? Okay, so I have the cat, and then 0.01. So what it's now going to do is it's actually going to extrude it via the sine curve, because you have that kind of back. So we now have the cat going, and then I can set this to like animate by 1. So now, I showed this to my girlfriend, and she was like crying and stuff, because this is what you do for a job? Yeah. Whereas you see this, you see the sphere's kind of pulsing, because all the normals are facing the right direction. Yeah, so you could do stuff like that. And then you could determine all sorts of crazy stuff. So you could do it via different waves. You could do it by cos. You could do it by tan. So now, did I actually save that? So yeah, tan basically is, it loops up and then sort of flips back round. So you can have stuff like this. So you could have the cat doing that in specific pixels. You could get the color of every pixel and say only the green things move. So you could have trees kind of like moving left and right. This is kind of just a simple example here. You could deform it. If I then go back and do sin, we can then have our cat sort of pulsing very gently. Yeah, it looks horrible. Okay, so that's kind of manipulating the vertex. You can go really in deep with this. You could have, say, a normal map scrolling and animating around it, pushing out all the points. And on Twitter, I post all sorts of weirdo GIFs and messed up stuff that I've done with shaders. And if you want any of them, just ask. So the next thing I'm going to do is I'm going to do something in the fragment. So we're animating or manipulating the vertex, and now we can do stuff in the fragment. So I'm going to make a cheese shader, which is the first thing that every single person does. So what we're going to do is we're going to write dissolve amount, because we want it to dissolve and cut out by a type of value. And it's going to say dissolve that cat. Yeah. We can also specify a range between like 0 and 1. So that way, if you have artists, they don't like kind of say, oh, I've set the value to be 2001 and it doesn't really work. You can set it to actually be a slider. So let's just set it to be like 0.5. And what I can also do is I can also take a texture and pass it in and not use it to draw on the screen, but take a texture and use it for any other thing. So I'm going to write a dissolve texture, or how it dissolves. So dissolve by this cat, and set this to be 2D, and it's white by default, and yeah. So next thing I'm going to do is then import it in, like always. So because the slider returns just a single value, it's dissolve amount. And because the other thing is a texture, we can then import in the texture. Okay, and then we can go down. So now that I have imported into CG, you can see here, I don't want to manipulate the object, I just want to manipulate the pixels on the screen. And this is where I look at my cheat sheet, which is somewhere, and this is where we could do this stuff. So like I've taken my texture and I've basically kind of stripped it out into individual pixels, I'm going to do the same thing. So I'm going to get the dissolve color equals texture 2D underscore dissolve texture in dot texture coordinate. I'm using the same texture coordinates. You could use other ones if you wanted to. And then we're going to use something from CG. So I don't think I have internet, but basically NVIDIA CG has lots of different functions to do all sorts of crazy stuff, like lerp between do values, dissolve, and one of my favorite ones is clip. So we're going to clip the texture clip the object by another texture. So in this case, I'm going to clip by dissolve color.rgb. We could also set it just be R, and we're going to subtract it by the dissolve amount. And if you look at NVIDIA's examples, they've got all sorts of crazy examples like this. So we're going to take the object, or take all the pixels, and clip it by this, which should return. OK, let's stop the cat from stop. If I now give it a texture, so let's use, which one? This one. So we then can clip it by this texture. So if you have a look at this, this quad here, what it's doing is it's taking the black points as a value of 0 and the white points as a value of 1. And you can see that as it then increases and decreases, you can then cut things out and do all sorts of stuff. So I could animate that whilst it's being cut out. OK, let's be a little kinder. Yeah. So you can see. And you could also pass in anything. I could pass in noise. So you could almost have like a dissolve thing. Like I think this is what they do in Super Hot. Like they dissolve it when you kill someone, maybe? Everyone here has played Super Hot, right? Oh, yeah. Super Hot. Yeah. And then I could also give it, I could even just give it some crazy stuff like this. So you could have like vegetation. But there's a couple of things that I don't like. So the first thing is if I look inside the cat, you don't really see the inside. And that's because by default, Unity doesn't really render the inside of the objects because it's kind of expensive. Again, we have magic methods to turn this off. So I can go to the top here where it says tags, and I could turn off culling. Cull off. So now here you can then see the inside and sort of the pass-through. You see it kind of pulsing and doing some weird stuff. And then I could pass in, that's probably look horrible. Yeah, that looks horrible. What am I doing? Or something like this. Yeah. So yeah, with shaders you can do all sorts of really cool stuff. Is that cool? Yeah. Maybe? Okay, so I don't have much time left. So if I go back to my fancy pants slides. So we've covered all the vertex and fragment. We've covered kind of this flow in manipulating data from one thing and in another thing. So let's talk about surface shaders. Surface shaders do lots. My favorite word is auto-magically, because lots of Unity auto-magically does stuff, and no one really knows how. So surface shaders do lots of cool stuff. So they automatically compute all object lighting. So if you have 20 point lights in your game, it will factor all those things in. Vertex and fragment, you have to write in the lighting from scratch and build that up. It also handles shadows, ambient lighting, reflections, 6 forms of light mapping that are in Unity, which is crazy, and also the whole PBR workflow. So surface shaders are pretty cool if you just want to drop a thing in and it to be shiny and have all this stuff built in. So the final drawing to the screen is different. So with the vertex fragment, you then return the pixel color for every single pixel on the object, or where the object is on the screen. Surface shader returns metallic map, smoothness, the alpha, occlusion, emission. It's kind of all the stuff that's like already you're used to if you're using the standard shader. So you could pass into things, pass into different slots. It's also a lot less code. So the default surface shader is about 41 or 42 lines of code, and it computes all that complex stuff. It automatically computes all of that. Now, in comparison to vertex and fragment, this is what vertex. So vertex and fragment, just to compute one texture and one reflection is that. Just to do one light and one shadows is that. Just to do simple light mapping is that. All of those 3 things combined still don't even achieve what this does here. You have to write a lot of code in vertex and fragment, which is kind of why I said, is why I kind of said that vertex and fragment is great for building things up from scratch. So you could write a shader that computes all reflections in your game, like water or something, but doesn't compute any lighting, so it's not, having that extra cost. Surface shader gives you a car, and then you drive the car from A to B, but that car may cost a lot of money. So yeah. So but the surface shader, it's a lot less code. But they do lots auto-magically, but this makes them overkill. So it's a big no-no for mobile no end. So the standard shader built into Unity is surface. And if you build that to mobile, you're already setting yourself up for bad performance. It's sometimes tricky to manipulate because they're kind of Unity-specific. And do you really need all those PBR outputs on your Match 3 clone? Do you really need all those PBR outputs on your 2D sprite-based game? Do you really need a mission on that? I mean, you could do if you wanted. But they actually make creating custom lighting a lot easier to do. So with like 5 lines of code, you could do some really effective stuff. And I always get asked this question: how do I make Watchmen in a game? How do I make Sin City? How do I make Wind Waker? Well, the lighting's very different. So normally in Unity, and if I go, oh wow, okay. If I get my balloon cat and set it to be a shader I've already written. So this is basically what the default surface shader does. So you can see here, you have here unlit for vertex fragment and standard surface shaded for all the lighting and stuff being computed. But you can see here that it automatically does loads of stuff. So if I start messing around with like lights and stuff, so if I rotate it, you can see that you have that nice tone across the object. If I delete it, you can see you have a nice attenuation from kind of the white areas down to the darker areas. Actually, the sphere is probably better to look at. So you see you have white areas here from the light of this direction down to the darker areas here. So it already calculates all that. But the way that cel-shaded games work, or like the way that Watchmen and stuff works, is it's kind of like banded lighting. It doesn't really have that smooth flow from A to B. It kind of has that sort of like chunky lighting. So, for example, here on Wind Waker, which is a game that came out like 12, 13 years ago, but still is better than some games today, which is crazy. Here you have a hard fall-off, not like a smooth fall-off from white to black. You have a hard fall-off. I know this is not a game, but whatever. In Watchmen, you have kind of the same thing. You have like highlights here closer to the light, and then kind of darker, and then you have darker and darker. And even in Sin City, you have like, you know, thick white from one section, and then at one point it just gets cut off. So that's actually really easy to create, and you can use this using a color ramp. So the color ramp will determine on the left-hand side the dark side of the object, on the light side, the lighter side closer to the light. And it's really easy to create. So again, demo time, because PowerPoint is boring. So if I go into here, I've already pre-written a shader because I knew I'd run out of time. So this is basically the default surface shader that you get. And it has the same makeup and build-up of the vertex fragment. So you can see here, we still call it shader. Let's call it custom. What's amaze in German? Wunderbar? No. Prost, yeah. Wunderbar, Prost, lighting ramp shade. You could also call it anything. So I could call it like a reference to super hot, Wind Waker. Yes. Wait. Hungover. Hungover, yeah. And it would then keep creating those slots all the way down. So if I choose here, you can see here we have custom, amaze, super hot, Wind Waker, hungover, shader there. So you can actually create all those different slots all the way down. So we can see here we have our properties, which are the public variables that we plug data into. We also have tags, like normal. You can also set LOD values. And you can also, here is where it kind of gets a bit different than before. So we have here, it's calculating all the lighting here. It's using a specific shader model. We're calculating in the main texture. You have the inputs. And then what it does is it kind of bypasses the vertex function and just goes straight to drawing the object on the screen. So you could overwrite that, but in essence, you kind of don't really want to, because surface shaders are supposed to be for just standard objects that don't do weird shit like turn into cheese. So what I'm going to do instead is I'm going to plug in my own lighting. So I'm not going to use the standard lighting where you have PBR workflow. I'm actually going to create a brand new one and call this amazing lighting. No, I can't do that. Someone give it a name. Does anyone know any names? I can't write that, sorry. Simon lighting. Okay, so Simon's sitting in the front. Okay, Simon lighting. We're going to create Simon lighting. So what we could do here is I'm then going to use Simon lighting instead of standard model. Go down here. Oh, I've Blue Petered it and just written it all beforehand. No one knows what Blue Peter is, so that's fine. And what we could do here is I'm going to use Simon lighting. And then here we can then pass in the value. So we're going to pass in the light direction, the attenuation from the light, and the surface output. And then here we're going to use a thing to work out kind of how the light falls off. And I have a nice diagram to explain this, which is this one. I did promise no big fancy pants algorithms. Luckily, it's quite simple. So for diffuse lighting, you need to pass in the normal from the object, so which direction it's facing in, or which direction each vertices is facing, and also the position of the light. So for example, here we have a sphere. The light is coming from this entity, or this area, and you have the normals pointing all off in different directions. So you can see here that the closer kind of the normal is to light, then the lighter it is, and kind of you have that smooth fall off to darkness. And this is where our color ramps come in use, these things here, because you can basically set, this is the darker side, this is the lighter side, and automatically do that kind of fall off. And here's some big weird image that I Googled like last night. Okay, so let's go back and do that. Oh, shit. Don't worry. So here we have the n.l, so we're going to calculate lighting from the light direction and the normal. We then also have to set that value between 0 and 1. We then do the same thing that we did before, where you do texture 2D, you bring in your texture, and then you set where it's going to be, and then we pass in the lighting as well. And down here, I also need to remove this, because we're not using standard lighting, and I'm going to turn off metallicness and smoothness, because they kind of irritate me. Oh no, we have an issue. Oh, I know what it is. Okay, I didn't import the ramp. So what we're going to do is we're going to make a new texture slot for just the color ramp, just the texture, and it should look fine. Okay, so let me delete that. So what you can see here is our object already has kind of like speckled lighting, because we haven't given it a color ramp. But really, I can go into here and I can say, actually use this texture with the left-hand side being the darker side and the right-hand side being the lighter side. And you can see here that we have a harsh fall-off. And I can rotate it, so we have kind of like, you know, thicker lighting. And the same with this object here. We could also pass in, if I choose the cat texture, you can see here that we instantly have kind of like a harder light. And if I rotate it, you can see it's much smoother. But rather than just using black and white because that's boring, we can then do sort of like banded coloring. And we could do stuff like this. Let me just turn off ambient lighting. So you can see here that we have our object, and then it's going to use that basically texture. And you can see here it does it as well. And you can also do all sorts of stuff. So you could like pass in colored fall off. So you could basically customize the lighting fall off. You could pass in textures like this. So this is then being computed in like, oh, that's horrible. Yeah. Definitely not helping some people who are drunk still. You could have kind of like greeny kind of, you know, like kind of that banding. And then you can see here that if I then pass in the cat, our cat then instead has kind of a bit more interesting like lighting setup. So you can see here that it's kind of, yeah, I'm making sound effects, but yeah, that's right. Or we could even go like, that's a bit more amazy, this one, yeah. So you can see here that we then have that nice fall off. Actually, nice, that's horrible. Or you could do like different colors, you could pass water in, like so we now have water as a lighting sort of fall off. You can go do all sorts of stuff. So yeah, you can basically plug in your own lighting and do some weird stuff. And similarly, I can go into here and I can say, and then I think I can subtract the value, so ramp, the attenuation negative, and then all the lighting is then reversed to the other side. Oh no, I've totally broken it, yeah. Oh, it should be negative ramp here. Nope, it's broken, whatever. Okay, we'll ignore that bit. Yeah, so we have that. But you can also do all sorts of crazy other stuff. So if I go into here, one of my favorite things is just writing weird shaders that do weird stuff, which is why I call it touch shaders, which is not a dodgy euphemism. And we can do all sorts of fun stuff. So for example, I have here like example of like kind of the Left 4 Dead outline. So here it uses a second pass, and it basically takes the first pass and kind of makes it slightly bigger, but kind of rendered behind it. And if I look at the shader and have a look at the CE for the shader, we can see here that we have our properties like normal. We have our tags to say, you know, what's transparent. So we have our first pass to actually draw the outline. And then we have down here our second pass to actually draw the object. So you have basically the same structure. You have vertex, you have fragment, you have all this stuff, but just in multiple passes, which is why we can then do stuff like this, and then set it to be, I don't know, like pink, and then make it like, yeah, you can make it do weird stuff. As well as doing that, you also have access to stuff like this. So if I go into here and go into this, we can then do a two-texture dissolve. So this takes texture A and texture B and then dissolves it. So kind of like I did that clip, rather than clipping, it's then going to dissolve between A and B. So you can see that I instead, yeah. And then if I have a look here, you can then go, shh. I can make this to be bricks, and then it fades between being bricks and cat. That looks horrible though. Like, yeah, and that's a really simple thing. I've just basically taken, I just put in two textures, the third texture. Oh, I have a thanks to Guillaume, who's one of our programmers, because he is the true shader god. And all we do here is then we have texture A, texture B, the masking texture. We then step between the values. So step will set it either to be one value or another value, and then we lerp it via an amount. So it's two or three lines of extra code to be able to have kind of like a nice dissolve. I've got kind of one more to show, I think. Ooh, where is it? It's a predator shader. Oh yeah, here we go. So this is kind of a weird shader. So if I pass in bricks, what it does is it basically gets the object on the screen and it kind of refracts it. So if you've seen Predator, the old movie? Yeah, maybe. Yeah, it's fine. So you can see here that as you look at it, it's basically taking it and refracting in the background. So kind of how water works. And luckily, that's actually a really easy thing to do. So all we do is, again, we import in the properties, but in this case, a bump map instead. We then use a thing called grab pass. So what grab pass does is it gets where the object is on the screen, and it gets all the pixels and kind of stores it as kind of like a sort of a shader-esque render texture of all the pixels. And then you can use that. You can then modify it. So kind of, you know The Sims when you go in the shower and there's kind of nudity, and it has that pixel-like overlay? Kind of that's kind of one thing you could use it for. And I just get in here and I multiply it by the magnitude. So I could have kind of like a Predator-style shader using like cracks and... That's not, okay, so that's technically broken because I'm not using a normal map, but I mean, I still think that looks pretty, it's kind of reflecting the sky and peeling and, yeah. Yeah, I still think it looks pretty cool. Yeah, and I've got a few more things to say. So what now? Okay, so we have our shader documentation online, which has various different examples, most of which what I've shown you is actually just in our documentation, which is cool. You can actually download all the built-in shaders in Unity and fuck with them. So, excuse my French. So all the ones that are currently built in when you click like material, like stuff like Skybox and things like that, you can't really modify the source code so everything is pink and stuff like that. But you can actually download them separately and go in and dig through them, strip them out, put them in A and B and stuff like this. So if I show you what they look like, right here, you can see here that you have all the shaders that are built into Unity for your enjoyment to play with, break. You can look at how the skybox is rendered, take chunks out of that and put it in another thing, and right there. You have all the terrain. You even have the shaders for the UI system that you can play around with and put text on a cat, I don't know. You also have the hidden internal ones that do some cool stuff. So, for example, you have the internal one for, where's the error one? Error shader. So this is what happens when you get shader error. This is just renders the object as pink. So that's actually a shader built in somewhere. You could use that in your game, although that would be horrible. You have a shader for flares. Yeah, you could go in and just mess with these, do what you want, sculpt with them. So yeah, play around with them. NVIDIA CG documentation is actually good, which is quite surprising. And they've got all sorts of different examples like clip and lerp and step, and basically different things that you can plug in. The Unity community, or as I like to call it, the Wild West, has all these different crazy shaders online that do all sorts of amazing stuff. And the forums are actually pretty good for people writing really, really weird stuff and people sharing it. Also, I actually find just Google searching insert game, not insert game name here, but stuff like, well, Team Fortress 2 is one of my favorite games. So passing Team Fortress 2 rendering techniques, Valve's released like 5 or 6 different publications on how they do all the rendering in Team Fortress 2 for free. So do that. You know, there's lots of stuff like SIGGRAPH papers and dev blogs and GDC talks where people talk about how they do that. So I think Firewatch did one about how they did the visuals for Firewatch. They actually used the Unity tree tool, which is quite impressive because it's quite old. Yeah. So for example, here with TF2, you show, oh, you've got the albedo. You then do that kind of color ramp, which is what I showed you, the ambient cube, and then they kind of show how they build up that. And that's all completely for free and readable and more. And go and experiment. It's the best way to learn. Like, just get things, copy-paste things in one place to another, break it, and then learn from that breaks. And then, yeah, hopefully I've condensed lots of information into a small gap. I know lots of people are very tired right now, and I apologize. Why am I apologizing for that? I'm not sure. But that's basically it. I'll be around all of today, so just come up and say hi, high five, play genital jousting, have a beer or whatever. I'll be around tomorrow and Saturday morning as well. If Amaze is on Saturday morning, I'm not really sure. Probably, yeah. Cool. I think I'm getting kicked off right now. Yeah. Yeah. Hopefully that was fun. Cheers.